We're going to look at radical expressions and functions. First, square roots. If a is a non-negative real number, then the non-negative number b, such that b squared equals a, is denoted by b equals square root of a. Is the principal. Principal square root means positive square root of a. This is a radical sign. The stuff underneath that is the radicand, and that's a radical. Now we're going to evaluate expressions containing radicals. What I've got in the box on the side, these are square roots that you need to know, and most of them you already do because you had to back when we were factoring. Square root of 64 is equal to 8. I've got a negative on the outside. The negative carries. Square root of 49 is 7. This is an imaginary number. We will play with them a little bit later, but right now we just say it's imaginary. You cannot take a square root of these individually. You've got to add them together and then take the square root. So square root of 25 is 5. If you try to do those individually and go square root of 9 is 3 and square root of 16 is 4 and then add them together, it's not going to get anywhere near that. So a square root works on a single value. This one, similar to that, except notice it's individual. That equals 7. In this one, I take square root of 1, square root of 4, gives me 1 over 2. Now these are a little bit different. They're different roots, but the idea is the same. In this one, cube root of 27, I'm looking for a number that if I cube it would give me 27. Well, if we played a little bit, 2 to the third would give me 8. How about 3 to the third? 3 times 3 is 9 times 3 is 27. So the answer to this one is 3. Cube root of a negative, I can take odd roots of a negative number. And on this one, if I do negative 1 times negative 1 times negative 1, that will in fact give me negative 1. So the answer to that is negative 1. This one, I do cube root of 1, cube root of 8, cube root of 1 is 1. Any root of 1 is 1. Cube root of 8, if you have an idea right there, it's equal to 2. And you can do those on your calculator. Let me bring my calculator over here. Under math, if you'll notice, I do have a cube root here, right there, and an x root. I'll show you that one in just a second. But let me get number 4. I'll press number 4, and I'm going to put 1 divided by 8, get out. I'm going to ask the calculator to give me my answer as a fraction. So I'm going to go math, frac, and there's my 1/2. 4th root of 16. Well, 1 to the 4th is 4. 2 to the 4th. See what 2 to the 4th is. 2 times 2 is 4 times 2 is 8 times 2 is 16. So my answer here is 2. Now that key that I showed you a minute ago, the xth root, you have to know the root before you press that key. So let me clear this off. My root is 4. Let me go to math, number 5, and do you see what happened? It moved. I'm going to type in 16, get out from under the radical, and there's my 2. This is an imaginary. I cannot take an even root of a negative. Now this one, the negative's on the outside. 4th root of 16, we already knew is 2. 4th root of x to the 4th, that's like dividing that by 4. It's just x. So that's what that one equals. This one, 5th root, I can take an negative. So a negative what? Check to see if it's 2. This one, square root of 49. Let me pull my negative down. Square root of 49 is 7. Square root of x to the 6th is x to the 3rd. Let me do this table real quick. We're going to complete the following table and graph the given function. Identify the function's domain and range. So if I put 0 in here, square root of 0 is 0, so 0 plus 3 will give me 3. Substitute in 1, square root of 1 is 1. 1 plus 3 is 4. Put in 4, square root of 4 is 2. 2 plus 3 is 5. Put in 9, square root of 9 is 3. 3 plus 3 is 6. So I've got 0, 3, 1, 4, 4, 5, 9, probably be about right there. So let me sketch. So my domain, as I come in, I hit an X value of 0 and it is used, and I exit out hitting an arrow, so that would be infinity. My range, as I come up, I hit a Y value of 3, and it also goes to infinity. So that's it for this video. Thank you.